Okay, now we look into detail equipment that being used to control particulate contaminants. Okay, so it can be divided into 5 major groups. The first one is gravitational settling chamber. Number 2, centrifugal collector, wet collector, electrostatic precipitator, and lastly, fabric filter. So which one to be selected depends on the size, distribution, the shape, density, stickiness, and also electrical properties. For example, if the particulate is in sticky form, dalam bentuk liquid, so fabric filter is not advisable. Okay, because bila sticky dia akan melekat dekat fabric, so fabric tu akan clog. Okay, so depends. So number 2 also depends on the carrier gas properties, the flow rate, and also the particle concentration. And lastly, depends on economic consideration. Okay, the cost and also operating and maintenance. Okay, for gravitational settling chamber, we have normal and also baffle. For centrifugal collector, we have a cyclone and also dynamic precipitator. For wet collector, we have spray tower, wet cyclone scrubber, and also venturi scrubber. Fabric filter is fabric filter satu saja, and also electrostatic precipitator ESP. Okay, now look at the first one, gravitational settling chamber. So this equipment menggunakan daya gravity. Okay, gravitational settling chamber. If you look at the diagram, okay, the gas flow in coming from left side. Okay, this is gas flow in. Ni yang kita punya air pollutants lah. Okay, the particulate air pollutants will be coming in from here, and then akan keluar sebagai udara yang lebih bersih at this side. Okay, the gas flow out. So inside here, in the middle, akan berlaku settling chamber. Okay, akan ada settling chamber where the particles akan jatuh melalui this chamber. Okay, so the cross-sectional area is much larger than the connecting duct. Okay, so dekat sini kalau tengok area dia kecil, so dekat sini area dia besar. Okay. So what happen if smaller area, so the velocity will be larger. So bila sampai dekat sini, dia dah velocity will be reduced because larger area. So dia ada masa untuk jatuh ke bawah. Okay, so at this area, all the particulate will be disposed of. Okay, at the chamber. Okay, and then yang keluar gas yang lebih bersih. Okay, this is how it works. It provides enlarged areas to minimize horizontal velocity. Okay, in the middle just now, you have a bigger surface area, so the velocity, horizontal velocity will be reduced and allow time for vertical velocity. So the particle will be disposed, okay, melalui vertical velocity to carry particle to the floor, okay, to the chamber. So usual velocity is about 0.5 to 2.5. And then we have calculation. This is the diameter of the particle. Okay, to calculate minimum diameter of a particle at 100% efficiency in a chamber. Okay, at a certain length. Okay, this one we'll look at example after this. Okay, how to calculate the minimum diameter at certain length given some velocity. For gravitational certain chamber, the advantages, this is a very simple in design and operation. It can remove particle more than 50 micron, and it employ only gravitational forces, okay, to separate particles. The disadvantages, of course, it requires large space for installation and also low efficiency for small particles, because kalau small particles dia akan just flow through, in equals to out. Dia tak sempat untuk jatuh because it's too small. Okay, and then number 2, centrifugal collector. This is as compared to just now, dia menggunakan daya centrifugal force, which is can be generated. Kalau gravity, natural forces. So for centrifugal force, it must be generated, and much smaller particles can be removed as compared to gravitational certain chamber. So two commonly used type is cyclone and also dynamic precipitator. Okay, so this is how it looks like, cyclone, and this is dynamic precipitator. Both use centrifugal force. So centrifugal force generated by spinning of gas. The magnitude depends on particle mass, gas velocity within cyclone, and also cyclone diameter. And then how it works, the solid particles are thrown to the walls as the gas spiral upward, and then the separation efficiency depends on the centrifugal force exerted on the particles. Okay, so this is the swirling gases akan produce centrifugal force. So dia akan langgar dinding, okay, the wall, and then akan jatuh ke bawah. All the dust will be collected at the dust outlet. Okay, so for cyclone, okay, if you can see here, this is okay, the diameter, the length has been dah ditentukan. So this is the proportion, L1 equals to 2D, L2 equals to 2D, diameter exit equals to half the diameter. Okay, and then height of entrance must be half of the diameter. For width must be quarter of the diameter, and the diameter of the dust exit must be quarter of the diameter, and length 1/8 of the diameter. Okay, this is the graph for particle size ratio. This will be used for the calculation later. Okay, so advantages of cyclone, it can increase smaller diameter multicyclone, increase the centrifugal force, will reduce distance of particles traveling before collection. And the disadvantages, problem with equalizing gas flow to each cone, akan berlaku plugging. Okay. Okay, cyclone we can divide into two, which is multi-cyclone and single cyclone. Okay, so as you can see, the dirty gas will be in at the bottom, in the middle. Okay, and then clean gas will be out at the top. Okay, so this is the centrifugal force, the swirling gases. So all the particles will be exerted to the walls and then can be collected at the dust discharge. Okay, so bila dia dah langgar wall, dia akan jatuh ke bawah. So yang udara lebih bersih akan keluar at the top. Okay, this is advantages and disadvantages for cyclone, single cyclone compared to multi-cyclone. So kalau multi-cyclone dia ada banyak tapi kecil. But if a single cyclone, the size much more bigger. So the sizes of particle determined by the following equation. Okay, later we will see in tutorial. And next is dynamic precipitator.